All right, so all right, when we are classifying triangles, we can classify triangles by their sides and we can classify triangles by their angles. There's a difference, though, in what we're looking at when we're classifying them by their sides and when we're classifying them by their angles. When we're classifying a triangle by its sides, what we're looking at is how many of their sides are equal. So in a scalene triangle, we have no congruent sides. Most of you have an idea of what the word isosceles means. There's just a tiny little nuance that you might be missing. What do you know to be the definition of isosceles triangles? Two congruent sides. The technical definition is at least two congruent sides.
So an equilateral is an isosceles?
Yes, an equilateral is, in fact, an isosceles triangle, but more specifically, it has all three sides congruent.
Oh yeah, that's confusing.
So everything that's true about an isosceles triangle, therefore, will also be true about an equilateral triangle.
So
It's like two triangles.
what if it's asking you a question and all three sides are congruent? Would it be equilateral?
You treat it like an equilateral triangle, yes. Okay, when we are classifying triangles by its angles, we're not looking at how many of the angles are congruent. We're looking at the measures of the angles. So when I say that a triangle is acute, I'm saying that all of its angles are acute. And what is a right triangle? Does it have all right angles? No, that's mathematically impossible. It has one right angle.
Square.
Same idea with an obtuse triangle. It has one obtuse angle. And an equiangular triangle.
They're all that same number that I can't think of right now.
All three angles are congruent. Yes, excellent observation. All three angles will be 60 degrees.
Or is that like 73?
73.
I don't know why.
But isn't that the same kind of for acute?
An acute triangle just means that all of its angles are
Below 9.
less than 90 degrees.
Oh, so one could be 80. One could be
Right. That's the idea. Yes, ma'am.
Could it be both? One?
What do you mean?
Like, could it be acute and equilateral?
Absolutely, an equiangular triangle will be acute.
All
Okay.
the time.
Do we have from this screen what we need? No, still get it. All right, so let's talk about some of the parts of isosceles triangles. And again, this may be terminology that you're familiar with. The congruent sides of an isosceles triangle, do you know what we call them? The congruent sides of an isosceles triangle.
On two side?
Well, let's start from let's start with the diagram then. In this isosceles triangle, you'll see where I have marked my two congruent sides. I call them the legs of the isosceles triangle. This is a leg, and this is the other leg. The congruent sides of an isosceles triangle are called the legs, and the third side is called the base. The vertex angle is the angle that is formed by the two congruent sides, so that would be this one up here. And base angles are the other two angles. So that's this. When that happens. Oh, that is not cool.
You got this. You got it. Just keep going.
One clap.
No, that's just not. That's not happening.
Oh. She's gonna read that. It's not. Yeah.
Okay, so the base angles
Are the two angles?
are these two down here, yes. And my diagram, as always, is far from perfect. But you can probably glance at it and maybe conjecture something about those base angles. What do you think might be something that's true about them? They are congruent, and that leads us to the Isosceles triangle theorem, which says if two sides of a triangle are congruent, then basically two angles of a triangle are congruent. More specifically, however, I want to be as specific as possible. If two sides of a triangle are congruent, then the sides opposite, the angles opposite those sides are congruent. And then you see that the next property on our screen is the isosceles triangle converse. There's that word again. Remember, when you're taking the converse of a statement, you're flipping it around. The isosceles triangle theorem, notice, says if congruent sides, then congruent angles. So if I flip that around, I'm saying if congruent angles, then there it is. So if two angles of a triangle are congruent, then the sides opposite those angles are congruent. We've used various different names for properties in this class. We've used the word properties. We've used the word postulate. Remember, those are properties that cannot be proven. They are so elemental to creating our special kind of geometry that we cannot prove them. And then we use those postulates to prove more properties, and we call those properties theorems because they can be proven. And then we have corollaries, which are almost like little children theorems that come so easily after another theorem. And our first corollary deals with these isosceles triangle converse and theorem and converse. And it says a triangle is equilateral if and only if what? Think about it. The isosceles triangle theorem and converse are talking about the relationship between congruent sides and congruent angles. So, Taylor, is that your hand up?
Yeah.
Tell me, please.
Sides and angles are congruent.
Basically, yes, a triangle is equilateral if and only if the triangle is equiangular. Which brings me back to the observation that Benjamin made earlier when he said, oh, an equiangular triangle, all of its angles will be 60 degrees. I would hope that you'd make the connection then if I know that the triangle is equilateral. That's enough for me to conclude that the three angles are 60 degrees. We're getting what we need from the screen. We good? In problem 1, we're being asked in part A if GK is congruent to HK. Look at the triangle, look at the markings, maybe turn the diagram if you have to, sometimes that helps. What do you think? Is GK congruent to HK? One person please, what do you think? Yes?
No.
Actually,
Yes.
yes.
Of course.
If it helps, as I said, sometimes turning the diagram helps. If I turn this diagram, look at these two angles that are marked congruent here. In that triangle. Notice the sides that are opposite them. So then GK will be congruent to HK. So for part A, it's yes, they are congruent. Here's my question. No, you were giving me the next one? Or you were giving me the reason? The reason. Give me the reason.
The isosceles triangle convex.
Fantastic. Yes, it's the isosceles triangle converse because I'm concluding that sides are congruent. In part B, we are being asked if HL will be congruent to KJ.
Triangle.
Right. Good. There's not enough information. No.
Yeah.
I love both answers. No, it's not a triangle. Not enough information. You have your turn there for problem 1. Please take a moment and work through that within your group.
This is a.
All right, let's go ahead and get started talking about the your turn for problem 1. Caitlin, tell me what you concluded in part A.
That angle WVS is congruent to angle S because of isosceles triangle theorem.
Good.
Because the sides are congruent, so that means that angles are congruent.
Beautiful.
And then TR is congruent to TS because of the two base angles.
Right. And I kind of took what she said and put it in words. You may notice up here that I have this whole transitive property up there. That's just in case you're kind of hazy about why angle R is congruent to angle S. What she concluded was that angle WVS is congruent to angle S because these two sides are congruent. What was given to us based on the markings was that angle R was congruent to angle WVS. So if you didn't just naturally make that connection, I showed you why you're allowed to make that connection. By the transitive property, I know that angle R will be congruent to angle S. So yes, TR will be congruent to TS because of the isosceles triangle converse. And then finally, in part B, I hope that you'd realize there just isn't enough information about triangle RUV to conclude that that triangle is isosceles. Okay, before I move on, any questions on either of those parts? Yes, sir.
So S is congruent to V, or
Yes.
WVS.
Yes.
And so since S is congruent to V, that means S is congruent to R because of, in the giant triangle. they're both the
Yes.
same.
Okay. In problem 2, it's asking us to solve for x. So easy, you could do it with half your brain behind your back. Look at it. You have two angles congruent. What's that mean? Then the two sides will be congruent. Your equation, ladies and gentlemen, is just 7x minus 10 equals 3x plus 6. Easy enough. 4x equals 16, and x is 4. In this specific problem, we are done. However, be ready for the idea of a problem where you're asked to find the length of the segment. In which case you would do what? Caitlin's favorite phrase?
Plug and chug.
You would plug and chug the x, the 4 in for x, yes. Okay, take a moment within your groups and look at problem 3. How would you find the measure of angle S? All right, let's go ahead and talk about problem 3. Ladies and gentlemen, one person please give me not just the answer, but a process. Sarah.
I did, because I'm on the other side, 15,
Name the angle that would also be 50 degrees. 3 letters.
L, and S.
Okay, the measure of angle LNS is also 50 degrees. And then?
And then I just took PLS, and since L would also be 50 degrees, I made that 100 degrees. But I know I did it in a weird way, but I think I got it right.
Tell me what you got.
80?
No. Okay, so wait. Okay, she gave us a good starting point. Who's picking up the baton from where she left off? Mariah.
Okay, so triangles are 180.
Uh-huh.
You would subtract it out of 180.
Okay, so she's taking 180 minus 50, and I have 130 degrees now left in this triangle.
And then you would divide it by 2.
And the reason why you're dividing it by 2 is because, notice,
Okay, guys.
since these two sides are congruent, these two angles need to be congruent. So I have 130 degrees left in this triangle to be divided among these two congruent angles. So that's why she's taking 130 and dividing it by 2 to get 65 as the measure of angle S.
When they ask you